Hello everyone and welcome back. So in the previous video we have learned how to create a peer connection and an RTC client to get ready to start a call with our target. And in this video we are going to create our repository to interact with socket clients and our RTC client. So to do that I'll create my repository and call it main repository. I'm gonna move this inside my main root. So this repository is going to be injectable and inject some variables. The first one is our socket client. The next one is going to be our RTC client. The next one is going to be JSON. And as usual, we are going to have an init function. Inside this function, we are going to have one username of type string and one password of type string, which can be null, and it will be null, and a local surface view renderer of surface view renderer type, and it's going to be null as well. Inside this function I'm gonna store all of these variables as a global variable. So private latent var of username, private var password of type string is going to be null, and private var local surface view of type surface view renderer, and it's also going to be null. And inside this method we're going to use them as the local variable. And so the next thing to do is to initialize our socket client and RTC client. So I'll write two functions, private fun init socket client and private fun init RTC client. And inside this function I'll get the username, same as here. Inside this function I'll just init my socket client using username and set the listener to this class. So as you can see we have the state of our socket, and I'm going to call this same as the RTC clients. Inside our RTC clients we'll also do the same. So RTC client.init, the username is going to be the username that I'm getting from my function signature, and the observer is going to be an anonymous object of type peer connection dot observer. But since this does have lots of abstract function, I'll create a class called peer connection observer. And this one is going to extend from peer connection observer and clear all of these to-do commands and go back here. I'll use this peer connection observer class that I just created. Forgot to make it open class. I'll just need to override on ICE candidate and on add stream. Just these two functions. Okay, so let's go back to our socket listeners, and whenever our socket is open we want to send a request to server for the sign-in. So right here using socket clients I'll send a message to socket, a data model which will have the type of sign in. The username is going to be username. The data is going to be password. We are sending password using data field to the server, and the target is not necessary, so we pass null here. And whenever we get a new message or a new event from the server, we have to handle the types and decide what to do when each type arrives. To do that, we'll use the when statement and check the message.type and implement all the types that we are going to use here. But before that, since this plug is running on the socket thread, I'm going to launch a coroutine scope of main and move this plug inside that. So there are some types that we don't care about them in our repository layer, which is going to be wrong JSON type, sign in success, user exists, start watching. We do need that. Don't need end call, wrong password, failed to find the user found successfully, and as else we do nothing. So these are the types that we are going to use in our repository layer. So let me create my functions and then start watching. Message inside. So I'll create all function signatures here. So whenever we receive start watching command, first we want to save a reference of our target inside our class. So private var target type string is going to be an empty string. And inside here, start watching, our target is going to be message username. So we realize who is the sender, and then the sender is our target, so we have to save a reference of our target. And after that, we start our local surface view using RTC client.init surface view and pass it, and then RTC client start local video capture using surface view render. And after that, we want to call the person that sent a comment that start watching. It means that a person asking us to start connection to him. Then we start calling him using RTClient.call. I'm gonna create an STP observer as a global variable. STP observer is going to be an object of STP observer. It's going to implement all the 4 members. And right here I'm gonna pass it STP observer, and as the target I'm going to pass the target to him. And the next case looks like we do have a conflict here, because this ice candidate is not what I have ported to my project. So I'll use the WebRTC ice candidate here, and here I'm going to remove this line that makes the conflict. So let's go back to our types, and whenever we receive an offer type, it means that somebody is trying to call us. So we have to use the session description that he's offering to us and set it inside our pure connection as the remote session description. To do that, I'll use the RTC client and call the onRemote session received function and create a session description of the RTC client. The type of it is going to be session description.type.offer, and the data is going to be message.data to string. And again, we are going to save the reference of the target. from the username that is sending to us. And after that, we do have to create an answer for the target that is calling us. To that, I'll pass the STP observer and message that username or the target. Doesn't matter. The next thing after that is whenever we receive an answer, which means somebody is answering our call and we just have to add its session description as our remote session description. So to do that, we will just have to use on session received and pass our session description to it. The type is going to be session description answer, and the data is going to be message.data to string. The next type that we have to handle is the ICE candidate. So whenever we are receiving an ICE candidate from the server, that we are sending this ICE candidate using this function and mapping the value of STP meet to a string. So we have to convert this map to a data model. To do that, first I have to create my data model. I'll create a new Kotlin class. It's a data class, and I'll call it my ICE candidate class. Inside that, I'll have STPM line index of type double, STP mid of type string, and STP candidate of type string as well. So let's go back to our repository and convert our message to our ICE candidate model. To do that, I'll create a candidate using try and catch block. In case of catching any exception, I'll pass null, but I'll use JSON library from JSON to convert my message.data to my ICE candidate class.java. But before that, let me convert this to a string of JSON first, using JSON to JSON and pass it to it. And after that, we'll check if ICE candidate or candidate is not null. Then we want to add it to our peer connection server using RTC clients add ICE candidate. But to do that, we need ICE candidate model from our WebRTC. So STP mid is going to be it.stp mid, it.stpm line index, and it's.stp candidate. And we have to cast this one to int. And the next type is going to be switch camera. To do that, I'll just write RTC client switch camera. And we will do the location, and on start watching location or start locating, we will do it on the next videos. For now, we handled all the types, but some UI events or some UI types we have to pass between repository and the UI view that is observing this event. To do that, we will have to create a listener from this class and pass it to the upper layer, which is going to be our fragment or activities watching. So I'll create an interface called listener, and I'll have a function on new message, which will have a data type of data model. And I'll create an instance of it. It's going to be a var of listener of type main repository dot listener, and it's going to be null. So I'll pass the rest of it to the higher level, listener, and pass message to it. Okay, so we're done with the socket clients. Let's go back to our RTC client. Whenever an ICE candidate is generated using our turn server, we want to send it to the target and also add it to our peer connection. So to do that, we do have a function called send ICE candidate. If you look at it here, you'll see first we add it to our peer connection, and then we will send it to our target. So to do that, using p0 as the candidate, and target is going to be our target, but this ice candidate is nullable, so we'll wrap it with the check. And whenever a connection is established and the remote stream is added to our peer connection, this function will trigger, and we will have the media stream that we have to show on our surface view renderer. So to do that, we will create a listener here, media stream, and create a function of on stream added, and the value of it is going to be exact same as this one, like this. And we will have stream listener of type main repository dot media stream, which is going to be null. Then we remove the redundant qualifier names, go back here, and then we'll just stream listener, the stream added, we pass p0 to it. We do have another conflict here because we have created a media stream interface. So to fix it, we do have to write org.webrtc media stream version. I'll copy this one and go here, paste this one here as well. We are almost done with our repository, but before we end up this video, we have to create some function like restart RTC client and the function of send switch camera command and function on destroy to destroy the whole process. To restart the RTC client, we have to release our surface view renderer, and then we'll close camera and then close the connection, and after that you'll restart or reinitialize our RTC clients. To send a switch camera command, I'll use my socket client to send a message. The message will be the data model, and the type of it is going to be switch camera. The username is going to be username, target is going to be target, and data is going to be null. And inside on destroy method, we will use the socket client to send a message which is going to be a data model, and the type is going to be end call. The username is going to be username, target is target, and the data is null. And after that, we'll destroy our socket client, and RTC client will close the camera and will close the connection. Okay, so right now we are ready to use this repository inside our parent and child fragment or activity, making calls and monitoring our child. That's it for this video. Till the next video, see ya.